All right, take two. Let's hopefully this works now. All right, so functions. That's the main thing we're going to talk about, but let's talk about relations first. Mathematical relations. And the biggest one that we have dealt with up to this point, we did a lot of this in geometry last year, are these things. Let's click off of that. Okay, here we go. So this is called a Cartesian plane. Or sometimes I'll call it a rectangular coordinate plane. Cartesian, I like that word because it's named after a guy with a girl's name. Well, back then, or even in France, it probably... Oops, I forgot something. All right, I think it's a little d. I'm not really sure exactly. I think it could be all capital D and then that C is little. I don't know. I think it might be that, but I'm going to write it like that anyway. That's how I remember it, but it might be capital D and a little c. But Descartes, okay, the S is not pronounced, it's silent. So René Descartes is actually a guy, lived from 1596 to 1650. So I actually outlived René Descartes. Well, of course, he was probably an old man when he died back then, because everybody died real young because they didn't have all the stuff, we have now. So what is he, 54 years old? All right, so anyway, yeah, so that's what this is named after. Let's not dwell on that too much. This has 4 different regions. What do we call those 4 regions? Yeah, but what do we call them? Quadrants. We call them quadrants, and we number them 1 through 4. And we use Roman numerals to number them. All right? And so this top right one is 1, and we go counterclockwise, 2, 3, 4. These 2 lines have a name. What do we call these things? Call it an axis. One of these is an axis. So this is the x-axis. You all remember this. Done this tons of times. And this is the y-axis. If you have 2 of them, if I talk about the x and y, what would I say? Would I say axes for the plural? It's axes is the plural. Okay, so axis is the singular. I'll just do this. Okay, so the singular is axis and the plural is axes. All right, good enough. So why do we do this? Well, we do this to figure out where numbers are located. Let's start right here where these 2 axes intersect each other. They intersect each other. We have a special name for that, a word for that. That's called the origin. Good. See, you've been taught this. I taught this to you last year. And you were probably taught this before last year as well, in Algebra 1, most likely. So we have this, the origin. Now, we got to get to a certain point. Like if I wanted to get to that point right there, and if I said... What if I wanted to get to that point? I called it point A. And I wanted to guide you to that point. You needed to get there. I'm like, okay, well, would you just go from here straight to there? That is actually a way to do it, but it's not a way that we're going to do it right now. Okay, later on when you get a little bit higher in math, we will go directly from here to here. But for right now, remember you got all these grids on here. Think of a graph paper. So what we do is we always go to the right first. That's the x direction, right? The x-axis. So we go right or left. And then you go what? Up or down, right? So if I wanted to get to A, I can only go in 2 directions. All right? It's kind of like a street. You're in Manhattan, right? Or downtown Philly. You can only go straight across this way, straight across this way. You can't go directly from this point to this point. So if I wanted to get to there, I start at the beginning, which is the what? The origin. And I go, which way? I got to go in the x direction first. So how many places? 1, 2, 3, 4 places in the x direction. We went to the right, so that's positive, and then we got to go up here. How far up here? 1, 2. So we give this a number, or we call it a coordinate. It's where that point's located. It's called point A, but where is it located? It's located at 4, 2. What does the 4 mean? The 4 means I go in the positive direction to the right. So I go to the right 4 places. What does the 2 represent? It means I go up. Since it's positive, I go up 2 places. So this would be a 4 and a 2. All right? It's called a coordinate, but it's also called a what? An ordered, remember? Pair. Good. It's called an ordered pair because it's in a certain order. What has to go first in an ordered pair? Which direction? The x direction has to go first, and then the y direction goes second. All right? So if they ask you, what is the coordinate of point A, you would say 4, 2. That's the coordinate. And you would write it in parentheses with a comma in between. That's the correct way to write an ordered pair. So let's go back to the quadrants. I should have done this before. In the first quadrant, every single point in that first quadrant, what are the signs of that x and y going to be? Positive and positive, right? Because to get in the first quadrant, I have to go to the right and I got to go up. They're both positive. What if I was in the second quadrant? What would the signs of every point be in the second quadrant? It'd be negative positive, because in order to get to any point in the second quadrant, I have to go to the left and I go up. To the left is negative and up is positive. What about the third quadrant? Negative, negative. Good. Whoops, what did I put an X for? Negative, negative. So I go left and I go down to get to any point in the third quadrant. What about the fourth quadrant? Positive, negative. Because I have to go to the right, I have to go down to get to any point in the fourth quadrant. That's pretty important. What if I had a point that lies right on one of the axes? Like right there. What if that point lies right there? What is the coordinate of that point? Well, where do I start? At the origin. First of all, I got to go left or right. How far do I go in order to get up there? No. How far do I go left or right? 0, right. So I go 0 left and right, and then I do what? I go up 2, which would be positive 2. Everybody see that? So that point right there would be 0, 2. What if I had a point right there? That point right there, we'll call that point B. What's the coordinate of point B? Negative 3 what? Negative 3, 0, correct. So I start at the origin, always start here. How do I get to this point? I have to go left and right first. So in this case, I'd go to the left 3 places, and then I'm already there. I don't have to go up or down, do I? So I go 0. All right, I think we have covered all of that. So they're going to give you a couple problems. I tell you what, let's do this. Just happen to have a little graph thing right here. All right, so they're going to give you a couple problems. They're going to say, this is example 1 in the book. They're going to say graph, or sometimes a book might say plot the points. You hear that? Plot the points. On this one, they just say graph and label each point. Graph, I won't write it down because of time. I got a lot more to do. So graph and label each point. So part A, they say, here's point A, and then they put an ordered pair right next to it. So what we're going to do is come over here on the graph. We're going to put the point where it's supposed to be, and then we're going to put a capital A next to it because this is point A. And let's write them all down. I think there's 4 of them. Yep. So B is at 3, negative 2. And then C, point C is at negative 1, 0. And then point D is at negative 3, negative 4. All right. Let's add a little splash of color here. All right, so here's our graph. So I got to go to 2, 2, 4. This should be super elementary for you. Would you agree? I hope so. Hope it is. So we start at the origin. We go 2, 4. To the right 2, up 4. 1, 2, 3, 4. Boom, right there. Do I just leave a point, go to the next one? Now I got to label it. So that would be point A. So put a capital A there. 3, -2. We go to the right 3. 1, 2, 3. We go down 2. 1, 2. That's point B. C is -1, 0. Start at the origin. You go to the left 1, and you don't go anywhere up and down. So you just stay right there. It's right on the x-axis, and that would be point C. Then point D would be -3, -4. So I go to the left 3, 1, 2, 3, and down 4, 1, 2, 3, 4. Right there, that's point D, and bam, there I go. I just graphed those points. We're going to be doing a lot more graphing later on in here, a whole lot more graphing, and it's going to be way more difficult than this, but we got to start somewhere, okay? So this is where we started. All right, enough of that. Now, why did they do all this? Well, I'm glad you asked. Because all of these are considered relations. When you have a relationship between an x and a y and you can get a point, that's called a relation, okay? It's from relationships, okay? They relate to each other, all right? This x and this y, they go together to make that point right there. Does that make sense? All right, so we call those relations. There's nothing super fancy about a relation, except now for the x and y, we give it a couple weird names. They're weird right now, but later on it's going to be so common, you hardly have to think about it. So these are relations. So if you had an ordered pair is a relation, but instead of referring to it as the x coordinate, we refer to it as the domain. It's probably a word you haven't heard in math before. And then we're going to refer to the y as the range. So anytime when they talk about the domain, find the domain, that's what they're going to say a lot of times. They're going to say find the domain. You're trying to find all the x values. Then they're going to say find the range. What does that mean? You're going to find all the y values. All right, so domain goes with the x and the range goes with the y. So, do you remember when you first started learning how to graph stuff? You made this little table. Remember that? Yeah. So, watch. 1, 3, 3, -1, 3, 2, and 5, 4. Okay? So what we're going to do is they're going to say, find the domain and range, like I said that they would do. Find the domain and range. All right, so we'll use D for domain. That makes sense, doesn't it? And we're going to put equals. And then for domain and range, they use these little braces. You've seen those before, haven't you? All right, they use this little brace to represent the domain and range. All right, so what we're going to do is we're just going to list everything in the domain. Now, if you notice, I got one. What are all the numbers in my domain? It's all the x's, right? So it's 1, 3, 3, 5. Now, if you have a repeat, you don't have to repeat it. When I ask for just the domain, you don't have to give me both 3s. Just give me one of the 3s. Say it again. One of them's negative. Which one? One of the 3s is? Okay. I didn't write that in my notes, but you probably are right. I probably just didn't write it down right. But I actually want to keep it like this for right now, okay, because I see something that I want to talk about. So in the book, one of them might be a negative. Which one's the negative, the first or second one? I don't know, maybe this wasn't even from the book. Maybe I just wrote it down because these are just notes that I took myself. Let's just stick with what I got up here, okay? Let's not worry about what's in the book. Let's just do this right here. So what if I ask you to list the domain, right? And also, you want to put it in, now right now, actually the range is not, but what I want you to do is put it in order, in numerical order, okay, from the smallest to the largest. Right now it kind of already is, isn't it, the domain? And again, if there's a repeat, in this situation there's a repeat, I don't want to repeat it when I write it in this little set notation thing. So what's my first value of the domain? It's 1. What's my next value? 3. And then my next one? 5. Again, if it repeats, I don't care. All right? Everybody with me on that? All right? Now they're going to ask for the range. So we put R. We put a little brace for that. Now, do you have any repeats on the range? No, but I wanted a numerical order though, okay? I don't want to go 3, -1, 2, 4. I want to put it in order from the smallest to the largest. So what's my first thing going to be in the range? It's -1. What's my next one? 2, then 3, and 4, okay? So if they just told me to list the domain and range, that's how they want you to do it. That's pretty simple, isn't it? Yeah, no biggie. A lot of times you'll see it like this. Now, I don't know why they put it in a circle or an oval, but they do. You've seen that before? Okay. Yeah. So what we're going to do is try to see what relates to what. So you got to go back up to here. You can't really tell just from this what relates to what. Let's go back to the table, right? So the 1 goes with the what? With the 3. See that 1 right there? That relates to the 3. Now this first 3 relates to what? A -1. And there's a reason we're doing what we're doing right here, okay? And then this 3 relates to what? A 2. And this 5 relates to the 4, okay? All right. There's something about this that we're going to talk about in a few minutes when we talk about functions, okay? Just kind of keep that in mind, all right? You don't see it. You have no idea right now, but you will in a few minutes, okay? Have I piqued your interest? Probably not. All right. Now, this is the actual example that the book gives. That was kind of like a pre-example, I guess, whatever. All right, so here's what they do. They call this relation E. All right, they just, that's how they name this relation with a capital letter. This is called relation E. You can use any letter. So this is relation E. Now on this one, they actually do the domain first. They write it in those little bubbles, -1, 1, 3. And then here's the range. It's -3, 1, 5. All right, and then they actually draw the arrows. So they do this part for you. So that one goes with this one. -1 goes with -3. +1 goes with +1. And +3 goes with +5. And here's what they ask you to do. They say represent this relation. This is a relation, right? This relates to that, to that, to that. Represent it as a set of ordered pairs, as a table, and as a graph. All right, so there's 3 parts to this. So we're going to represent it as ordered pairs. All right, so how do I write that as an ordered pair? So -1 goes with what? It relates to what? -3, right? So that's my first ordered pair. Do you see that? This is my domain, that's my range, so I know this is my x, and that's my y. And I know that this -1 relates to -3. All right, so I write it like this. What's my next ordered pair? This is super easy. This is not, I'm not like tricking you or anything. It's that easy. So 1 goes with 1 and what? 3 goes with 5. So there's my ordered pairs. What's the second way? They wanted you to write this as a table. What was the table up here? It was this thing, this x and y, all right, with that going straight down. So let's do a table. So I put the x's on the left, the y's over here. Let's scooch this down a little bit. All right, that's pretty easy, right? -1 goes with -3, 1 goes with 1, 3 goes with 5. We wrote it as a table. And then the next one, it says write it as a graph. All right, so we'll just do a little sketch. Doesn't have to be super accurate. So what's the first one? -1, -3. There's -1, 1, 2, 3. Boom, right there. This is 1, 1, so that's 1, 1 right there. And then 3, 5. 1, 2, 3. 1, 2, 3, 4, 5. Right there. There it is. There's your graph. That's all they ask you to do. All right. Let's do another one. This is example 3. This time it says state the domain and range. State, I'll just put D and R, is that all right? Domain and range of each of these. So this is part A. This time, instead of calling it relation E, they call it relation F. You can use any letter that you want. And so here is the relations. Again, at first, these are pretty simple. But this is the one example where it's going to get a little different. And 4, 4. All right, so there's that. So super easy on this one, okay? Again, this is not a trick question. It's that easy. So let's find the domain. Here's your relation right here. Okay, it's written as ordered pairs, and you just want to find the domain. So what do we got? -2, 0, 2, 4. And it's already in order, isn't it? All right, so that's nice. So I just write those numbers, -2, 0, 2, 4. All right. Let's do the range. Now remember, on domain and range, you want to put them. If they ask you to list the domain or list the range, you want to put the things in numerical order. So am I going to start with 4? Well, actually, yes, I am, because what? They're all 4s, aren't they? They all go to 4. All right, so what am I going to put for the range? Just a 4, and that's it. Okay? It's as easy as that. Now, here we go. All right? Not trying to scare you off or anything, but this is a little bit different. So this time, they're not just going to give you a bunch of ordered pairs. They're going to give you a graph. And they're not just going to graph separate points. Because if they just graph separate points, that'd be pretty easy, right? You just take the x's, that's the domain. You take the y's, that's the range. But watch what they're going to do this time. They're going to give you a point -1, -3. 1, 2, 3. Everybody see that? That's at -1. That's at -3. I'm sorry, I shouldn't have. They make it open. Okay? Then they give you another point, 2, 3. 1, 2, 1, 2, 3. And they make it closed. And you know what I should do? Make this pop a little bit more. Make it red. And now what I'm going to do is I'm going to connect from here to here. So this, it's a little bit different. So we're not just talking about individual points, are we? All right? Natalie, this is one thing I would stay awake for. Okay? There's no way in the world you should have your head down. So it's everybody look up here. We did easy stuff. All right? We saw the domain is the x, range is y. No big deal. Ordered pairs, simple. This is a little trickier. So what I want to do is I want to find the domain and range of this graph. So first of all, what's this point right here where I put that open circle? It's what? -1, -3. Okay, but does it include a -1 and -3? No, because it's an open circle. Remember, open circles do not include that. But it includes everything along that line. How many ordered pairs do I have along that line? A lot? More than a lot. What's more than a lot? Say it. I can't hear you. You're whispering. You're whispering. I can't hear you. Say it. What are you going to say? I thought I heard you say it. Yes. Is that what you said? Yeah, that's what I was asking. I wanted you to say it bold and proud. All right? There's an infinite number. There's an infinite number of points along this line. How in the world am I going to sit there and write an infinite number of ordered pairs? I can't do that, can I? So what I need to do is find out what are all my possible x values. Okay? For instance, is -2 one of my possible x values? No, because it stops right here, doesn't it? Okay? In fact, -1 isn't even one of my possible x values. Okay? Where does it go? How far to the right does it go? 5? 5 is out here. Does it go to the right? Well, it doesn't stop here. Look at my x value. My x's run this way, don't they? Look at this thing right here. How far do they run? They run all the way to here, don't they? That's all my x values. From here to here. You see that? Because why did I put that point right there? Because this drops right here. So you have to think just along the x-axis. What are all my possible x values? Well, everything from where? From -1 all the way to where? To +2. So how do I show that? So x can be everything from -1 all the way to what? +2. But can it include -1? No, because it's open. So I don't put a or equal here. Can it include +2? Yes, because it's closed. So what do I need to put right here? Or equal. That is my domain. Does that make sense? Natalie, if you're not going to pay attention, you can just leave. Is that what you want to do? Pay attention. If you don't feel good, go to the nurse. Okay? I'm not going to put up with having anybody's head down and not paying attention. So here's the domain. I didn't draw that very nice. Okay, so from here to here is your domain. But I don't really write a line there. I just think visually, okay, along the x-axis. What x values exist on that line? Everything from where? From -1 up to +2. It just does not include the -1, but it does include the +2, and that's how we write it. See, x is greater than -1, and x is also what? Less than or equal to 2. Does that make sense? Yeah, we did that stuff in the last chapter, right? With that inequality stuff. Yeah, that's why we did it, so we could get to this. What about the range? The range are all the y values this time. Let's put that in a different color. What are all the y values? From here all the way up to here. So where am I right here? -3. Where am I up here? +3. Okay? So what are all my y values, the range? Everything, watch, I'm going to put a y right here. I'm going to put less than, less than. Everything from where? -3 up to +3. Do I include the -3 here? No, because it's open. Do I include the +3? Yes, I do, because it's closed. So I put a or equal at the +3. And that is my domain and my range. So that's where it gets a little bit tougher, okay? But it's still it should make sense on what we're finding, right, with domain and range, because we're trying to find all the x values of that line segment, and all the y values. So all my x values, remember, there's an infinite number, correct? Everything between -1 and including +2. Those are all the domain, that's all the x values. So just think of it of being like an infinite number of ordered pairs, all right? But I can't write that, obviously, so this is how I write it. This includes everything along the domain. This includes everything along the range. Does that help a little bit? All right, let's do another one. Now this graph, it's kind of funky looking. Actually, I'm not even going to use that thing. Let's just do this. And I'm going to do this in a different color. I'm going to try, I'm not very good at drawing these things, especially on this, but I'm going to try. It's a curve. All right, try to make it as smooth as you can. Mine's not the greatest, but you get the idea. It should be a nice smooth curve around like that, okay? And what do you think they're going to ask you to do? Find the what? Find the domain, and then find the range. All right? So the domain are all the what? All the x values, right? So I want to look at this graph and find out what x values are included on this graph. Now, you've never done a graph like this, okay? You may later on in this year, okay, figure out how to do this, find the equation of this graph and stuff like that, but not right now. But just looking at it, you should be able to look at it and say, what are all the x values for that graph? First of all, let's find out what the x values are not. So I don't have any x's where? To negative, right, along the x-axis. I don't have any along there. But it does hit right there, and it definitely hits right there. So what's the first x value? It's 0, correct. So my first x value is 0, and then it keeps on going this way. This is an arrow, so that keeps on going. This keeps on going. So it's going to be everything what? Greater than or equal to what? 0. And that's your domain. Does that make sense? So you don't have any negative values, so you don't have anything less than 0 on the x-axis. All my values, because look, if I put a point right here on the positive x, it will relate to, right, relations, remember that? It will relate to a y value. It will relate to 1 here, and it will relate to 1 here. Yes? Okay? And so that is my domain. Oops, if I can draw that kind of thing. What about the range? The y value. Say it, Noah. It's everything. It's all the y values. Because look, this y will keep on going up forever, but eventually it'll hit that curve, won't it? Everything below here, see how this keeps going down, 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 down? Every y value is going to be here. So how do I show all the y values? I just say all the real numbers. I had a fancy way of doing that. Do you remember that? Yeah, that double R looking thing. So that means all the real numbers. I don't think you really need to put that in a brace, but I'm going to. I didn't do that on my notes. I don't know if they do that in the book, but that's okay. So you can just put that. If you wanted to, you could just say what? All the real numbers. All right, so that's pretty easy. Now, remember that one I said we want to remember? Let's do this. Remember this one right there. Remember I said we're going to get to that in a few minutes? Okay, now we're ready to get to that. See how that 3 relates to the -1 and it relates to the 2? So that x value right there relates to 2 different y values. So let's skip down to here. Let's take this x value. This x value relates to this y, and it also relates to that y. Everybody see that? Okay. The next word, what's the next word on this lesson? Functions. Functions are kind of like relations, okay? Every single relation is a function, but not every function, I'm sorry, let's say it this way. Every function is a relation, but not every relation is a function. Oh, are you kidding me? I'm not looking at the clock. I need to do that. All right, well, that's a good place to stop. We'll do functions tomorrow. So we're already, day one, we're off of our, I think, our lesson plans. What did I say we were doing tomorrow for the lesson plans? Do you remember? Let me flip to mine. Oh, good. So I did do that. Good. I made plans for that. So let's see. What do you have? 1 to 22. You should be able to do 1 to 22. So number 1 to 22, we're going to call it section 2-1A. That should just be all relations. I don't think that has any functions in it. It does have functions? Okay. Well, do as many of these as you can, all right? Tomorrow we'll do the functions, and then you should be able to finish this up, okay?